Hello everyone, this is your teacher talking to you here, and it's long time no see. I wish that you all safe at your houses, and I wish that you are interested in learning more about physics. So let's start where we stopped before. We'll start with the vector operations. Just a quick reminder, but that quick reminder should be with a sample problem. So, as you can see, we have a problem. The problem talks about a hiker that walks a distance 27 kilometers from her base camp at 35 degrees south of east. Remember, we have to put all the four directions all the time to remember where is my direction. So the four direction, you remember the four arrows with north, south, west and east. He's saying that the next day she walks 41 kilometers in a direction 65 degrees north of east and discovers a forest ranger's tower. Find the magnitude and direction of her resultant displacement. Now for any vector we have to draw. So to draw you have to put it, as you see here, this is x and y direction. So x and y direction, and then one of them was 35 degrees and the other was 65 degrees. But remember, if the angle is at the direction clockwise, so when it is clockwise, that means it's gonna be negative, which is theta 1, negative 35 degrees. And if it is counterclockwise, like theta 2 here, it's gonna be positive 65 degrees, positive. Now he's asking you to get the resultant displacement. So what is gonna be the displacement d? And he's also asking you about the direction, which is theta. So for such problems, we need to look to the problem to find the x and y component of all of the vectors. So we have two different vectors. The first vector, which has negative 35 degrees, theta 1, for this one it has d1 of 27 kilometers. So for such a vector, it should have delta x and delta y. And the law for delta x and delta y for whenever we have a degree, so the delta x will be d multiplied by the cosine of that angle, which is cosine theta 1, while delta y is gonna be the displacement d1 multiplied by the sine of theta 1. So remember, delta x, which is close to theta, it will be cosine, while delta y, which is opposite to theta, will be sine. So d1 multiplied cosine theta 1, this is delta x1, and d1 multiplied theta 1 multiplied cosine sine theta 1, this will be delta y1. If we calculate both of them, we can get those numbers over here, delta x1 and delta y1. We can go the same for day 2. So day 2, situation of 65 degrees, but we have d, which is d2, it's gonna be 41 kilometers. We will apply the same rule. Delta x, whenever delta x, see, theta is close to delta x. So to get delta x, delta x2 is equal to d2 multiplied cosine theta 2, while delta y, which is opposite to theta 2, delta y2 is equal to d2 multiplied sine theta 2. So now we have delta x2 and delta y2. Once you get delta x1, delta y1, delta x2, delta y2, then you can get the delta x and delta y for total. Delta x1, delta x total, it's gonna be delta x1 plus delta x2, while delta y total is gonna be delta y1 plus delta y2. Remember, it's straightforward. Whenever you have a problem, even if that problem is complex, even if you have a vector, whatever vector it is, try to make that vector to be delta x and delta y. Only delta x and delta y. And whenever you want to get the resultant or the total of that, you do the summation of delta x, all the delta x's, and you do the summation of delta y, which is delta y's. As you can see here, once you get delta x total and delta y total, remember the first law for the total displacement. Total displacement, which is d, is equal to the root of delta x total square plus delta y total square. And from that you get d, and you can get also theta, which is tan negative 1 of delta y over delta x. It's gonna be 29 degree. When it's 29 degree, that means it is opposite to clockwise. Opposite clockwise or counterclockwise. Okay, now we will deal with another problem, but before dealing with that other problem, let me go to a new lesson. So we have a new lesson now. Once we done from this example, we will talk about a new lesson. So that new lesson for today is gonna be projectile motion. So projectile motion. So the objective of projectile motion, I want you to recognize some examples of projectile motion and describe the path of projectile as a parabola. So this is very important. Projectiles are objects that are thrown or launched into the air and are subject to gravity, and they are called projectiles. So projectile, it's very difficult. It's curved. Whenever you throw something, it has a curved path, and the air is all the time causing resistance, and that resistance is causing the projectile motion. See here at the red ball, you can see it's going straight forward, while for the yellow ball, you can see that it is going with a projectile motion, which is parabola-like motion. So this is an example of projectile motion. I want to show you the kinematic equation of projectiles, but first let me show you a video, nice video for the projectile motion. So let me show you a video of David Beckham is doing unbelievable 3 balls, trying to throw them into the trash can. See David Beckham, he's trying, he has a ball, he's on the beach having Pepsi, and he will do see the balls.
David, you think you can get that trash can over there?
Yeah.
Really? How about all 3 of them?
It's even easier.
What? Okay. Here's the
Try
one.
to get it into the trash can, David Beckham.
Come on.
See? This is a projectile motion.
No freaking way.
See the motion? This parabola thing is exactly
Oh man,
this parabola motion is projectile motion. Now another projectile.
Yes!
This is projectile motion. And nice one, David Beckham. So you can say that one of the very important thing for projectile motion is kinematic equation. See, the gravity is doing a big effect. So kinematic equation in the horizontal and vertical direction. As you can see, that gravity, which is acceleration, at the y direction, which is gravity, so ay is negative g, or the gravity. It's negative 9.81 meter per second square, because this is gonna cause the ball to fall down, like Beckham in his video. And in the horizontal direction, the acceleration was 0, because there is no motion at the horizontal direction. The direction was mainly at the vertical direction. So the velocity is constant. When you have the acceleration is 0, remember, the velocity is constant, because acceleration is equal to the change in velocity over the change in time. You will remember this forever. Acceleration is equal to the change in velocity over the change in time. We talked about this at the first trimester. We will take it all the time and everywhere, that acceleration equal to change in velocity over change in time. Also, for the kinematic equation, you should know that the initial vertical velocity is 0. So whenever the ball is reaching to the highest point, so its velocity gonna be 0, and the horizontal velocity is the initial horizontal velocity is the initial velocity. So remember, the projectiles always launched at an angle, like David Beckham, what he was doing with that challenge. He was throwing the ball with an angle. It was very fascinating. See, he's throwing the ball with an angle theta, and he's throwing it with a velocity vi. And now let's remember, see, this is a vector, it's called vi, and there's an angle theta. Do you remember we were talking about vectors when they have an angle theta? All the time try to split it into delta x and delta y, but here instead of velocity I, it's gonna be velocity x and velocity y. Velocity x, or velocity xi, is equal to vi multiplied cosine theta. Remember, because it's x, vx is vi cosine theta, while vy is gonna be vi multiplied sine theta. So this is very, very important. Now let's take a sample problem. Projectile launched at an angle. Is a zookeeper finds an escaped monkey hanging from a light bulb. Aiming her tranquilizer gun at the monkey, he's trying to shoot the monkey. She kneels 10 meters from the light bulb, which is 5 meters high. The tip of her gun is 1 meter. So remember, so she has a gun, and that gun has a tip, and the tip is 1 meter above the ground. It's as if, like, you know, those guns that you play with the kids with a ball on it. Whenever you throw it, you have to throw it with an angle to get the ball into the monkey, or to get the shot into the monkey. At the same moment that the monkey drops a banana, the zookeeper shoots. If the dart, which is the shot of the gun, travels at 50 meters per second. Will the dart hit the monkey, the banana, or neither? That looks like very interesting and very challenging problem. But to solve the problem, it should be easy. You select the coordinate system. So remember, you have vi, and vi there is theta. And now he's telling you that you know it's 10 meters far away, and you know that you are 1 meter above the ground. So the ground is 0, x and 0, y, and you are 1 meter above the ground. And you know you are 4 meters below the top, or below the top where the point of the monkey is. And you are delta x of 10 meters. So delta y is 4 meters, delta x is 10 meters. Now you want to solve the problem, so you use the invert tangent function to get the angle. Remember that theta equal to tan minus 1 delta y over delta x. At this situation, delta y is 4 meter, as we can see, and delta x is 10 meter. You get the angle, which is 21.8 degree. Once you get the angle, you can know that delta x is equal to vi cosine theta multiplied delta t. So delta x will be equal to velocity x multiplied delta t. Delta x is velocity x multiplied delta t. And velocity x is equal to vi multiplied cosine theta. As a result, you can get the delta x as a function of delta t. This is the equation, general equation. But you know, in this situation, you know the delta x, and you know also the vi, you know the theta, your angle, we calculated before, and from that we can get the delta t, which is the unknown. Once you get the delta t, you can find out how far each object will fall during that time. You know the time that will take the shot to go over there. Now for the banana, you know that the banana starts falling from velocity I equal to 0. Once you know that delta yb for that banana will be falling. It's a function of the acceleration, half acceleration multiplied delta t square. From that you can get delta y, or the y direction for the banana. Once you get the y for the banana, you can know for your dart that has an initial vertical component of velocity equal to vi cosine theta. So at this problem, we know delta y for the banana, and you know also delta y for the dart. From that, you can afterwards know that y for the banana. So once you know delta y for the banana, you can know what is the height, or y for the banana. It's y initial for the banana plus delta y banana. So delta y banana is by negative because it's falling down. For the dart, you know y initial for the dart plus delta y for the dart, because it's a positive because the dart is going up. From that you can see that the height of the banana and the dart are almost the same. So eventually, for this case, the dart will hit the banana, and that slight difference is due to rounding. With that, I want to finish what we have taken today. I gave you an example of projectile motion. I showed you a video of David Beckham playing using projectile motion, and I wish you learned and remembered some equation about projectile motion. Now you should give yourself a try and go for your classwork, which is solved for this week. But give it a try and try to apply those laws at your problems. I wish you all to be safe, and please have fun while you are at home. And having fun means that you can apply physics in lots of things, but do not try to do like David Beckham and throw your ball at home. Wish you all the best.